The Earth may seem massive and awe-inspiring, but it's only a speck in the vastness of the cosmos. Technology has enabled us to explore this great unknown, sending rockets and satellites into space to uncover the mysteries that lie beyond our own planet. Our curiosity is driving us ever onward, each new discovery inspiring us with fresh wonders to uncover. We long to unlock the secrets of the universe and explore its infinite depths. How do we do that? Well, with the Voyagers sending us information to process. However, things haven't always been so seamless. For the past couple of months, we had no contact with the Voyager, and after months of silence, it's back with an unexpected discovery. Join us as we get to the bottom of everything that happened and what the discovery means for the future of humanity. But before we get into that, let's dive into the Voyager mission as a whole. How it all began. The launch of Voyager and Voyager 2 was an event that would forever change the course of history. On the 20th of August 1977, Voyager 2 launched off into space. Its mission? To explore the vast reaches of our solar system. But this was only just the start. Shortly after it left Earth, NASA made history by capturing a picture of both the Moon and the Earth in one frame. The Voyager mission's primary purpose was to explore the outer planets of our solar system, but it also had a second goal, sending back data about the stars and interstellar environment beyond. To accomplish this, the spacecraft had been equipped with sophisticated instruments to monitor its surroundings as it travels through space. These instruments have allowed us to collect information on magnetic fields, particle densities, radiation levels, and even the properties of interstellar clouds. Voyager was also equipped with a unique communication system so that it can send data back to us from its travels through deep space. This communications system was critical for understanding what Voyager is seeing as it passes by planets, moons, and stars alike. Voyager 1 followed its sibling closely after on the 18th of September 1977. Now, with both spacecraft on their way to explore and document our corner of the universe, a journey like no other was beginning, one full of discoveries that would astound us. From its launch onward, the mission promised to be truly extraordinary. It was a journey to uncover the secrets of our solar system and delve deeper into what it had to offer. The future looked bright for Voyager and its mission ahead. No one could have expected the abundance of information that this project would bring us in the decades that followed. The mission had been perfectly plotted out. Despite the common assumption that our solar system is round, it's not. Instead, all of the planets orbit in an irregular oval, and there are only certain movements in time when they align in a way that would make space travel efficient and effective. August and September 1977 was one such window, a rare opportunity where all the planets along Voyager's journey would be in its path. This meant that it wouldn't need to deviate much from its route, making the mission both possible and successful. It was truly a remarkable moment in history. The stars and planets seemed close enough to touch as the $865 million probes left Earth, hurtling out into deep space. In a single year, they had made it all the way to Jupiter, defying expectations and sending back an astonishing 4,000 images of the gas giant up close, and 2 new moons. An additional ring had also been discovered, leaving scientists in awe. It was clear that the mission had been incredibly successful and that all the effort put into preparing these probes was worth it. Every moment they sent back more information about our solar system, small glimpses of things we were only beginning to understand. But with each new discovery, things became even crazier. Who knew what they would find next? The possibilities were infinite. What did the Voyager find? One of the most notable times we heard back from the Voyagers was when Voyager 1 captured a breathtaking image of Earth from 11.7 million kilometers away. The very first time a photograph of both Earth and the Moon had been taken from such a distance. This was incredible because it gave us true insight on how the Moon and the Earth come together as one unit, something we'd just been theorizing about until that point. To think that this box of wires and metal hurtling through space at immense speed was able to take such an incredible photo from over 11 million kilometers away is simply mind-blowing. It's remarkable that we as humans have been able to create something so amazing and advanced that can do this. On March 5, 1979, Voyager 1 took its first picture of Jupiter from 57.6 million kilometers away, an amazing feat in itself, but this was just the beginning. On March 9, 1979, volcanism was discovered on the Galileo moon after analyzing a picture captured by the probe. It became one of the first times it was even thought possible for that to happen. This was around the time that we first lost contact with Voyager 1. It was a very scary moment for everyone at NASA and for the world. After all the time, resources and dedication put into this mission to explore our solar system, it was nerve-wracking that something could have gone wrong. It was something that hadn't ever happened before, so let's just say that the team at NASA worked day and night to get the connection back. While there was a period of uncertainty there, eventually they were able to establish contact and get things back in order. Just when we thought things couldn't get crazier, on November 11, 1980, Voyager 1 had its first flyby of Titan, Saturn's largest moon and the second largest in our solar system. The data and images sent back to Earth showed us a world far more complex than we had ever imagined. One of the most significant discoveries from this encounter was that Titan is not as large as originally thought. Scientists had previously estimated Titan's size to be anywhere between 6,000 to 6,500 kilometers in diameter, but Voyager 1 showed us that it was actually only 5,150 kilometers across, about 25% smaller than what scientists had originally predicted. Voyager 1 also revealed a mysterious atmosphere on Titan that was 10 times thicker than Earth's. It contained nitrogen and a variety of organic compounds, hinting at the possibility of life on Titan. The probe had also found that Titan had an abundance of methane lakes and seas, making it one of the most Earth-like objects in our solar system. All in all, Voyager 1's flyby of Titan was a monumental success. It showed us that there is still so much to explore and discover even in our own solar system. Eventually, the spacecraft would also reveal the true largest moon in the solar system. Voyager 1's flyby of Ganymede on June 5, 1979 was a significant moment in our understanding of this moon and the solar system. Before the flyby, we had very little information about Ganymede and what it looked like. Its size was also unclear, with estimates ranging from 3,000 to 5,000 kilometers in diameter. Voyager 1's close-up images of Ganymede revealed an icy surface with extensive cratered terrain and strikingly showed that its size was much larger than previously thought. In fact, it is the largest moon in our solar system at 5,268 kilometers in diameter, just slightly larger than Titan. The pictures taken by Voyager 1 also reveal a unique geological feature called grooved terrain, which are narrow lines and ridges that run parallel to each other in the moon's icy surface. Scientists believe this was caused by a process called diapirism, where warmer material from the interior of Ganymede rises and breaks through the cold, brittle ice crust. By this point, it was clear that the billions that went into this project weren't for nothing. They were bringing in unheard-of information one step at a time, and while the initial idea was just to have the Voyagers check out our solar system, by this point it was clear that both of them were more than capable of venturing into the beyond and still send us information. So, at this point, the new plan was to let them go into interstellar space, should they make it there, and finally get a look at what's really beyond our solar system. On November 12, 1980, Voyager 1 made its closest approach to Saturn, coming within 121,000 kilometers of the planet's cloud tops. During this encounter, the probe revealed to us an incredible world filled with fascinating features like colourful clouds, swirling storms and icy rings that stretch for thousands of kilometres. Nearly a year later, on August 25, 1981, Voyager 2 followed its companion's wake. On January 24, 1986, Voyager 2 made its closest approach to Uranus. This historic encounter revealed an icy world filled with remarkable features like blue-green clouds and a complex system of narrow rings. The probe also found that Uranus had 11 distinct moons: Miranda, Ariel, Umbriel, Titania, Oberon, Cordelia, Ophelia, Bianca, Cressida, Desdemona, and Juliet. Voyager 2 also identified two previously unknown rings, the Epsilon and Delta rings, which are both composed of small particles ranging in size from tiny dust grains to pebbles. The data and images sent back from this encounter revealed a world far different than what we had imagined. Scientists discovered that Uranus had the coldest atmosphere in our solar system, with the temperature hovering around -224 degrees Celsius on average. We also learned that it has an enormous magnetic field, which is oddly tilted and aligned differently than the planet's rotation axis. On February 14, 1990, Voyager 1 snapped the iconic family portrait of our solar system. This image is made up of 60 individual frames that have been stitched together to create a single mosaic. It shows 6 planets: Mercury, Venus, Earth, Mars, Jupiter, and Saturn, as well as their respective moons in a single view. The image also includes a view of the Sun, which appears as an off-white dot in the lower right corner. The shot was taken from a distance of 6.4 billion kilometers, more than 40 times further away than Voyager 1's flyby of Saturn. At the time it was taken, this shot was the most detailed image of our solar system ever captured. It showed us how small and fragile our home world appears from such a great distance. The portrait also serves as a reminder that, even in the vastness of space, our planets are part of a single family. By February 1998, Voyager 1 had outrun even Pioneer 10, becoming the most distant human-made object in space. In an incredible feat of engineering and exploration, Voyager 1 pushed through interstellar space in August 2012, followed by its companion Voyager 2 in November 2018. In August 2012, Voyager 1 became the first human-made object to reach interstellar space. This is a region even beyond the heliosphere, which itself is the bubble of charged particles that surrounds our Sun. At this distance, it was able to measure the density of hydrogen atoms in the interstellar medium, which is the material between stars. Scientists were able to confirm this when the spacecraft detected a higher than expected level of hydrogen, indicating that it had crossed into interstellar space. In November 2018, Voyager 2 became only the second human-made object to reach interstellar space. After traveling for more than 41 years, the spacecraft had reached a distance of 18.6 billion kilometers from our home world, more than twice as far away as Voyager 1 at the time of its crossing. Voyager 1 has been journeying through the vastness of space for 45 years and is now 22 billion kilometers away from Earth. But that doesn't mean it stopped making astonishing discoveries. In March 2019, scientists working with data from the Voyager 1 spacecraft detected a faint hum in interstellar space. The hum is made up of low-frequency radio waves that measure between 3 to 25 MHz. The waves are believed to be caused by turbulence in the interstellar medium, the region between stars. This turbulence is thought to be created by magnetic fields that interact with each other and cause fluctuations in the density of particles. The hum had been previously detected by Earth-based observatories, but it was only recently heard by Voyager 1 as it had traveled far enough away from our Sun to detect the low-frequency waves. Scientists believe that this discovery could help them better understand how galaxies form and evolve over time. From the start, plasma has been part of Voyager 1's mission. and the spacecraft has observed lightning strikes in Jupiter's atmosphere and studied how solar winds slow down at the edge of our solar system. Here, the solar wind, a constant flow of charged particles from the Sun, was no longer powerful enough to block out interstellar medium, thus opening up a new world of discovery. Even since then, the plasma surrounding Voyager 1 has been closely monitored. Overall, the Voyager 1 may have been one of the most important space exploration endeavours ever undertaken. It revolutionized our understanding of the solar system and provided us with the first ever close-up images of planets, moons, and other bodies. But it's the Voyager 2 that put everyone in a frenzy more than a few months ago. Radio silence. In March of 2020, NASA dropped a bombshell. The Deep Space Station 43, or DSS-43, located in Australia, is the only antenna on Earth capable of sending commands to Voyager 2. The DSS-43 is a crucial part of the deep space communication system, allowing both NASA and other space agencies to maintain contact with their spacecrafts. However, in March 2020, it was announced that the DSS-43 was to undergo critical renovations, meaning that for 11 months, no communication would be possible with Voyager 2 as it continues its journey through deep space. This decision was caused by a number of factors. The age of the station, combined with the strain of continuous use and environmental damage due to its location in the southern hemisphere, have caused the station to become unreliable in recent years. As a result, it was necessary to upgrade the station's hardware and software as part of an effort to maintain reliable communication with spacecraft such as Voyager 2. Engineers at NASA will use this time to upgrade the station's hardware and software, as well as install new antennas that will increase its range and sensitivity. Once the renovations are complete though, communications between Earth and Voyager 2 should resume with increased accuracy and reliability. Scientists were understandably concerned as Voyager 2 is now over 18.7 billion kilometers, 11.6 billion miles from Earth, and rapidly getting farther away with every passing moment. Without the ability to send commands and receive data from Voyager 2, scientists would be unable to study the environment of interstellar space or monitor the spacecraft's performance. In addition, without communication with Earth, it will be difficult for the onboard computer to remain powered and functioning properly. Without regular maintenance, Voyager 2's systems and instruments could begin to fail, leading to a loss of valuable data or a complete breakdown of the spacecraft. Furthermore, without communication with Earth, the spacecraft is left vulnerable to unexpected events in deep space. If something were to happen, such as an unexpected collision with a piece of space debris or a solar flare, it is possible that Voyager 2 would not be able to report the incident. Even if it did manage to do so, the data may not reach Earth in time for scientists to act on it. However, there was a glimmer of hope. Although the craft would remain unable to receive any transmissions, its own signals back to Earth would still be heard. This is due to the fact that Voyager 2 is equipped with a variety of instruments and sensors that can collect data on its environment, such as radiation levels, temperatures, magnetic fields, and more. This data can then be transmitted back to Earth, even if the craft cannot receive commands or other transmissions from mission control. Overall, although communication with Voyager 2 will be suspended for 11 months, there is still a glimmer of hope that scientists can collect data from the craft and be alerted to any emergency situations. After months of hard work, the renovations to DSS-43 were ongoing and on track for completion in February 2021, but that didn't stop mission operators from testing the waters. NASA still conducted tests with the Voyager 2 in this period, despite its lack of communication. In November 2020, mission operators issued a critical series of commands to the craft and waited for its response. Although they knew they wouldn't receive any data back until late 2021, they wanted to ensure that the upgrades were functioning correctly and that the spacecraft was still in good health. This was done by sending the craft a series of wake-up commands and observing its reaction to them. If Voyager 2 responded as expected, it would be a sign that all of its systems were functioning correctly. In addition, mission operators also sent commands to turn off certain instruments and test the onboard computer's memory to make sure it was functioning properly. The wait was worth it, Voyager 2 replied. It was 100% okay and on its course to deep space as the teams at NASA were expecting it to. With each message, it would send more details about interstellar space, the things it discovered in the beyond, and, well, not all of those have been expected. Astronomers at Cornell University have likened the detection of a solar outburst by Voyager 1 and the information the Voyager 2 has sent to that of lightning bolts during a thunderstorm. It is an awe-inspiring sight to behold. Previously, scientists thought these shocks were the only way Voyager 1 could measure the density of the plasma in interstellar space. Solar outbursts are powerful eruptions from the surface of the Sun, like solar flares and coronal mass ejections. These events can cause a shock wave to propagate through interstellar space that Voyager 1 and 2 were able to detect. This discovery was made possible due to the two crafts' capability to measure plasma densities along their journey. The density of the plasma in interstellar space is difficult to measure because it is so sparse. Scientists previously thought that only shocks created by solar outbursts could be detected due to their increased densities, which is why the discovery made by Voyager 1 and 2 was so exciting. The hum that was detected by Voyager 1 was instrumental in making this discovery. The waves of the hum are created when energetic particles interact with the interstellar medium, creating a low-frequency hum that can be heard. Scientists have used this hum to determine that there is more plasma between solar outbursts than previously thought. Thanks to this mysterious hum, scientists can track the interstellar medium between shocks, allowing them to gain even more insight into this remarkable journey. It's a discovery that could prove invaluable in our ongoing exploration of the cosmos. It means that we can now learn even more about the way deep space works and how it may affect us on Earth in the future. And on that note, we'll wrap up today's video. What do you think about the unexpected cutoff we had from the Voyager spacecraft? What do you think they mean? Could everything always be on course, or is an outside force messing with the Voyagers?